Okay. In a previous class we considered a problem, then I was working it out, but then I left it halfway through. I thought you would give it a try. So, let us solve that problem first and then we will consider the subsequent topic. The problem that I gave was this, that there is a fair coin, means the probability of having head or tail, in either case is half, and then coin is tossed thrice, and the random variable x equals the total number of heads. Okay. So, I have to find out the probability distribution and therefore, probability density function for the random variable x. So, that time we consider this. So, these are the possibilities, that we can have tail, 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 then tail, tail h, tail h, tail, okay, 1, 2, 3, 4, 5, 6, 7, 8 combinations. So, only in this case no head occurs, means the random variable x takes the value 0. Probability of this taking place is, probability of tail is 1 by 2. So, 1 by 2 into 1 by 2 into 1 by 2. Okay. So, that means x equal to 0, probability is 1 by 8. Okay. In this case, we have got head occurring once. So, the random variable x takes the value 1. In this case also h occurs once, then in this is another case, and in all other cases h occurs more than once. So, on 3 cases only we have got a combination where h occurs only once and tail occurs twice. So, occurrence of h has got a probability 1 by 2, other 2 has probability 1 by 2 each. So, again 1 by 8 here, 1 by 8 here, and 1 by 8 here, okay, here, here and here. So, that means x takes the value 1 with probability what? 1 by 8 plus 1 by 8 plus 1 by 8, because these are mutually exclusive, these combinations. So, probability is 3 by 8. Then consider the cases where x takes the value 2, that is, let us look for those combinations where h occurs twice. So, this is one of them, this is one of them and this is one of them, which means x equal to 2 has a probability 3 by 8, all right, and then x equal to 3, means all the 3 trials give you h only. So, you have got only one such combination, clearly the corresponding probability is 1 by 8. Now, we have to convert this information into probability distribution function and thereafter probability density function. Okay. So, let us consider this. X taking the value 0, it has got probability 1 by 8. And this will remain so until and unless x becomes equal to 1. When x is 1, that time the probability is 3 by 8. Okay. So, what is the probability that x takes value either equal to 1 or less than 1, that is 1 by 8 plus 3 by 8. Okay. So, there is a jump here by an amount 3 by 8. So, that means this point is, if you add 1 by 8 plus 3 by, with 3 by 8 you get 1 by 2. So, this is 1 by 2 and this remains so till you have got this point x equal to 2. Okay. When x equal to 2, what is the probability that x equal to 2? Again 3 by 8, which means what is the probability that x takes the value less than or equal to 2? That means we have to have a jump by another 3 by 8 here. Okay. So, that makes it 7 by 8 I guess, and this will remain so till 3. Here there will be another jump by 1 by 8 and then it will saturate to 1. So, this is the probability distribution function for x. Obviously, the probability density function will be the derivative of this. Now, these flat regions will give derivative 0 and at these discontinuities we will get impulses. Each impulse will have a strength equal to the difference between the two levels. So, you have got one impulse here, another here, another here and another here. This has got strength 3 by 8, 3 by 8, 1 by 8, 1 by 8. Okay. This is not a very difficult problem and I guess all of you have been able to solve this. Nevertheless, in case somebody had doubt, one can just take a relook into this and then clarify his doubts. Okay. So, let us now consider the next topic, that is in the previous class. In the previous class, what we did is this, just to recap, x was given to be a random variable and there is a function, deterministic function g of x, which was evaluated every time the random variable x takes some value. Okay. For convenience, we all considered real valued random variables and functions which are real valued. That function was called y actually, y equal to g of x. So, since x is random, y also is random. Probability distribution function for x was given, g x was given, our task was to find out the probability distribution of y. So, we considered various ways. We started with some particular y, we tried to find out the possibility or the probability of y taking values less than or equal to that value. Okay, this is evaluated for various cases. So, this we know now. We have to do a similar exercise for the probability density function. In fact, we have to find out, we have to derive some closed form relation, whereby giving the function g of x and giving the probability density of x, how to find out the probability density function for y. Okay. That is, obtain okay. Now, in general, as I mean in our case rather, as I told you, x takes real values and gives a real valued output y. So, in fact, you can have a relation written like this, y x, and given a particular g x you can have the plot. Now, x takes real values from minus infinity to plus infinity, that is given. Okay, that is x takes real values, all possible real values. Now, y has this axis. So, let us start this way, that suppose there are certain regions on this axis which are not touched by this function g x. That is, you put any value x, evaluate g x, you can never get values in those regions, if such regions exist. For instance, suppose g of x is such that its maximum value is 5. So, naturally, y greater than 5, that is, if you find out the point 5 here and look above along this axis, that entire region is something for which, I mean, you cannot get a g x, that is, you cannot find any x for which g x will be equal to that. So, those actually give rise to improbable events which are probability 0. So, let me write down formally that if a set so that for any y element of S y there does not exist, this means there does not exist any x element of this real line, this is for real line, so that g x equal to y. If that be so, that is there are some segments on this axis, together they form a set say S y. The set S y is such that you whatever x you take, evaluate the function g x, that can never be a member of that segment or that set. Okay. If S y be such a set, then obviously for any y belonging to S y, the corresponding probability will be 0, because these are impossible events. Okay, because you can't get any x for which g of x can give you a value from within that set. So, these are impossible events. Okay. So, for that probability will be 0, that I write in the next page. In that case, this value y actually is taken from S y. That is a trivial case. So, let us now consider only those segments or that part of this y axis for which at least there exists at least one x, if not more, on the real axis, on the x axis. So, that g of that x gives rise to this value y. So, these are not improbable events. Okay. So, consider so that if you really want to solve this equation, that put this value you have chosen, this capital Y, and find out for which x you get this, you will get real real solutions for x. That means, there exists some value, one value or many values on the real axis for which the function when evaluated on those values gives rise to y, that is leads to real valued solutions for x. Okay. We will find out the probability density of y, p y capital Y for such case now. Earlier we consider such, this capital Y such that even if you try to solve it, you do not get any real valued solution for x. So, on the real axis you cannot find a x for which g of x gives rise to this y. So, these are improbable events, these are probability 0. Now, we are considering the other case. Well, instead of just getting a general result, or maybe I give the general result first, and then instead of proving it for the general case, it will be, I think it will be perfectly all right. We just take a special kind of function, any arbitrary function, and and show how the result comes. Then you can always generalize that. Okay. I say that suppose I am solving this. Raised to solutions. Again, for the time being, you can assume that you have got just finite number of solutions, as if this is a polynomial of some finite degree, and you have got the solutions. For a particular y, you are solving this equation, the solutions are given by x equal to say x dot 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 dot. Maybe I will not take the number of solutions to be finite, let it be dot 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 dot. I mean, it does not matter whether you have got infinite solutions. Yeah. Okay. These are the solutions. So, g of x 1 is y, g of x 2 is y, g of x 3 is y, and like that. In that case, for a given y, the corresponding probability density will be we put that one solution here and divide it by the derivative of the function g x evaluated at this value and take its mod. Then again p x, put the second solution x 2 divided by the same derivative, mod value of the derivative, but evaluated at x 2 and dot 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 dot. Okay. Do it for all the solutions. This will be the probability density. Okay. Now, instead of taking a most general case, we just consider a particular form of g x where you have got just as 3 solutions x 1, x 2, x 3. From that only we will try to obtain this result, from that we will try to obtain this result, and that logic will be clear to you. So, that you can always generalize that result to this context. Okay. Now, suppose I just consider a function like this. Or maybe this is the function g x, this is the x axis. And the corresponding probability density for x, that also I plot. Okay. Now, suppose you are given a y here and y plus dy here. In fact, I just rewrite it. Some value y, capital Y, and plus dy here. So, I have to find out what is the probability of small y taking values between capital Y and y plus dy. That probability will be the probability density times dy, right. We have to evaluate that. But let us see, when we have this capital Y, it intersects this function g x, this is g x at 3 points. That means, it has got 3 solutions. You can even call them this is x 1, x 2, x 3, and as we go up, let us see what happens here. Here we have got this part. this part is dx1 . But here this part, this is dx2 and here this is dx3. You can see dx1 is positive, this has a positive slope. So, it is positive because y can increase only if x increases. Here also it is positive because if x increases, this increases because the slope is positive, but here the slope is negative. That is why dx2 is in this direction negative. Okay. So, what is the probability of y remaining between capital Y and y plus dy? That is same as the probability of x remaining between capital X1, that is, let me write down this way, probability of y this will be what? Either x would be here or here or here. In fact, this area and this area. Summation of the three areas will be the probability of this, or will be the value of this. Okay. That is, this will be this time x2 plus dx2, that is this point, okay, x2 plus this point, but that is to the left. Plus okay. This is the probability. Now, first evaluate this. What that will be? Let us consider term 1. This is sorry. This is term 1, this is term 2 and this is 3. Number 1 will be what? Very simple. Number 1 is probability density at this point times dx1. Okay. Number 2 will be what? Probability density at x2, but not times dx2, because dx2 is negative. I am only interested in this area. So, as per the definition, this is the probability density here multiplied by this time mod dx2. Okay, because probability cannot be negative. And number 3 is very simple, p x x3, no need to put a mod, it does not make any difference though, dx3. Now, you can always put a mod across dx1 also, dx3 also, because even otherwise they are positive. So, it does not matter. So, to construct the general result, I will put a mod across them. Anyway, so this probability will be what? This plus this plus this. This is still not what, not equal to the result we quoted, but it is not very difficult to obtain that from here. Let us find out what is dx1 before I go to the next page, because that time I will not have this figure with me. What is dx1? dx1 will be, now I know that if you take the derivative here, g prime x at x1, I can call it g prime x1, that is nothing but dy dx1, which means dx1 will be dy by g prime x1. Okay. Likewise, that means if you want to put a mod across this, you have to put a mod across this, but dy is always positive. Dy was in our control, we took y equal to some value capital Y and then went up y plus dy. So, dy is positive. So, you need to put mod only here, because gradient can be both positive and negative. Okay. Similarly, we can write down okay. So, now if we put them back, we get the probability of y remaining in this range, which by definition is nothing but dy that is equal to this into dx1 mod, but that is equal to this. So, dy sorry px again dy So, you take out dy from both sides and you get the result. Okay. So far so good. Just only one thing I need to add here, that suppose the function y equal to gx is such that it has got some flat portion, something like this. As we discussed in the previous class, there will be a discontinuity due to this in the probability distribution function. Just for convenience, we can even take a recap of that. Suppose you take your capital Y to be here, then your f y capital Y, what will that be? The total probability of x remaining less than or equal to this value. Okay. Then slowly suppose capital Y is brought down and this point also moves to the left, this decreases. Obviously, this is a non-decreasing function, in fact, it is an increasing function most often. So, this will decrease smoothly as this starts falling and this goes to this left point, this starts falling down smoothly, gradually, smoothly, continuously. After it reaches here, that is when I am here. So, this is particular value y 1. Then I have got some value for f y y 1 also, that is the total probability of x taking values either equal to or less than x 1, that is fine. But as I try to slide down, immediately I cross this distance and I move here. Okay. So, there is a huge jump because I am crossing this distance. Earlier when I was here at y 1, I was considering the total probability of x taking values up to x 1. Immediately after that, I am going up to x 0 or even to the left of x 0 and progressively far and far to left of x 0. So, there is this jump by how much? That is probability distribution of x up to x 1 minus probability distribution of x up to x 0. That is the total probability of x lying within this range. By that I am jumping. So, there is a discontinuity. So, if there is such discontinuity in the probability distribution function, if there is such discontinuity in the function g x, obviously, if you are looking at a y 1, if chosen a y here y 1, the corresponding derivative, so there are infinitely many solutions. Earlier we took y equal to some capital Y, we had 3 solutions, x 1, x 2, x 3. Suppose function g x is like this and you choose this y 1, this level only. So, there are infinitely many solutions in this interval x 0 to x 1, and for each of them, this derivative is 0. So, there will be division by 0, that result is not valid. You have to, for such cases, you have to look at it from a different angle. Since the probability distribution function at those points will be, I mean, if you plot f y versus y, there will be some discontinuity at y 1, it is going up, then suddenly it is going up, I mean it is jumping and going up, saturating to 1. Okay. Since probability density function is nothing but derivative of this with respect to y, at this point there will be an impulse. Okay. That is, in this case p y y, I would say y 1 will be nothing but an impulse at y 1, that is delta y minus y 1, means there will be an impulse here at y equal to y 1, and of what strength? Strength is this, which is nothing but what is the amount by which we have this discontinuity, that is what is the amount of discontinuity? That is probability distribution up to x 1 minus probability distribution up to x 0, which means equivalently net probability of x lying within this range. So, that is, sorry, this is okay. This is a word of caution. Now, we take some examples. One, y equal to g x equal to a x plus b. Okay. In this case, as you know, it is a linear function for giving any particular y equal to capital Y, there is a unique solution only, okay, some capital X, and that will be given by capital Y minus b by a. That is a unique solution. Okay. G prime x is a, okay, and given y, if y equal to capital Y, it gives rise to a solution x is equal to, from this equation, y minus b by a. This is the only solution. So, you can straight away apply the formula, you get this. Sorry. One by mod of this at this point capital X, but then this is independent, this is constant, it is independent of x. So, just put a mod a here, okay, and p x, what value? Replace x by this, express the solution in terms of given y, put that here. Okay. As for example, suppose this x is a random variable now, it is not taking the entire real axis, it is within some range. Okay, it is a uniform random variable within a range x 1 to x 2, that is, suppose p x capital X is like that. What is the height? Area should be equal to 1. This is a rectangle, once this side is x 2 minus x 1. So, height will be 1 by x 2 minus x 1. Okay. Suppose this is the case. So, x is not taking the entire real axis, x is taking only values between x 1 to x 2, okay, and within this range its probability density is fixed. In this case, p y y by that formula 1 by mod a p x y minus b by a. Okay. Since this is uniform and this is just a constant, this is also uniform. Okay. This is also uniform, and in what interval? If x takes the value x 1, y takes the value y 1 equal to how much? A x 1 plus b, and if x takes the value x 2, y takes the value a x 2 plus b. P y and p x, they have the same form, it is just a constant. Okay. So, this is the thing. Okay. It is it will y also will be uniform in the interval. Okay. So, this is a simple example. Next, we consider slightly more complicated case. Okay. Y is equal to a x square. So, this is your g x, and given that a is a real constant and positive. Okay. First, x is of course, as I told you in the beginning, we are taking real valued x only. So, x square, whether x is negative or positive, this is always positive, a is positive. So, if on the y axis we are considering the negative range of y, then that amounts to an impossible event, because there cannot be any real x for which y by this formula will become negative. Okay. So, if y is less than 0, obviously p y is 0. Okay. So, we will not consider this is a very trivial case. So, now consider y greater than equal to 0, this case. Here for given any y, you have got solutions. How many solutions from this? This is a quadratic equation. So, you have got 2 solutions. With a plus sign and x 2 with say minus sign, or maybe you could call this x 1 and this x 2, because in my figure x 2 was greater than x 1, it does not matter though. These are the 2 solutions. Okay. So, that means, and what is g prime x? G x was a x square. So, g prime x will be twice a x. So, that means, given any capital Y, this will be what? They have got 2 solutions. So, there will be 2 terms. One term is, put the first root with a plus sign divided by twice a into this and then since we are putting mod, even if I have minus sign, the mod operation will take care of it. So, essentially I get back. Okay. In this case, you cannot say that if this is uniform, x is uniform, this also will be uniform. There are 2 terms. Okay. If you plot this probability density, plot this probability density and superimpose them, you will not get a uniform. In fact, you will not get a uniform in general. Okay. We consider the next example now. Clearly, for any x, negative or positive, this is a e to the power x is a positive number. So, that means, if y, in fact, this can never be, if we are not considering minus infinity, this can never be 0 also. Anyway, if y less than 0, obviously p y is 0, because that is an impossible event. There is no x for which you can get e to the power x equal to some negative number. Okay. Then, given y greater than equal to 0, what is x? Solution is ln y, this is number 1. And what is g prime x? That is e to the power x, which is y itself. Okay. In this case, and there is only one solution. Given y, there is only one solution, by the way. This is not a periodic function or a function of such kind where you have got multiple solutions possible. No. Given a y, you get only one x. So, it is a very simple case. P y y, this will be what? P x you have to put the solution. The solution is this ln y divided by mod of this. Okay. In fact, I would say rather that remove this equal to part and put this, otherwise no, there may be a division by 0 occurring here. So, I have a mod of g prime x, okay, that is mod of y, capital Y, but capital is already positive. So, we will have this thing. This is the probability density. Okay. As for example, suppose x is given to be Gaussian, okay, of mean mu, okay, that is say x is given to be normal or equivalently Gaussian, both the terms are used, mean that is, this we have already covered in the class, this particular form. Okay. In that case, P y will be what? By our previous formula, there will be one y here, okay, and you have to replace this by the solution, that is ln y, rest is same. Okay. So, this becomes root 2 pi sigma y e to the power minus ln y minus mu whole square by twice sigma square. This is called a log normal density function. Okay. All right. Next example. Again, this is slightly more complicated. Suppose y is g x is given to be something like this: a sin x plus some constant theta, where a is real, theta is real, a is greater than 0. Okay. So, this function y, obviously it cannot take values beyond plus a or minus a. Okay. Y cannot take values beyond plus a and minus a. That means, if capital Y is less than, sorry, there is a mod value of this is greater than a. If the mod value of this is greater than a, in that case obviously P y is 0. On the other hand, so we will be considering y mod y less than a. In this case, if you put capital Y here, since this is periodic, you will have infinitely solutions like this. Suppose your y is here, this is your capital Y. You will have one value here, another here, you can call it x naught now. This is x 1, this is x minus 1, this is x 2. Likewise, so you have got x 0, x 1, x 2, x minus 1, okay, x minus 2 and like that. So, infinite many solutions. So, you have to use that formula for each of these solutions. Okay, you have to use that formula for each of the solutions. What are the solutions in general? X n is nothing but sine inverse of what? Y by A minus theta. The sine inverse is an angle, you can always, and this is periodic, it does not have only a unique value, you can have value various values, that minus theta will give you this. So, these are the various solutions. Okay. And what is g prime x? G prime x will be a cosine x plus theta, which is nothing but what? Very simple. Y is a sin x plus theta. This is a cos x plus theta. So, what is this? If you square them up and add, you get a square, which means this is nothing but a square minus y square. Okay. In this case, what is p y y? Is nothing but, and this is common for all x, for any solution. You have to put various solutions for x, but for any solution this is common and this is independent of the solutions. So, this is a common factor, and then summation n from, you can say, minus infinity to infinity p x x n. Okay. Special case, x is uniform between minus pi and pi. So, that means it will have a probability like this, sorry. And this is 1 by 2 pi. So, that the area is 1. So, this is independent of x, and quite clearly if x is taking values only between minus pi to pi and in no other range, then I can have only two solutions in minus pi to pi from our previous figure. You can call one x 0, another x 1, but for both of them the corresponding probability is 1 by 2 pi. So, in that case p y, capital Y is very simple. This is just 2 times, because I am summing twice, 2 pi, 1 by 2 pi, again 1 by 2 pi, and this factor a square minus y square is common. Okay. So, that is all for today, and we will take up from here in the next class. Thank you very much. Okay. So, today we discuss some important concepts like mean and variance. Now, we are given a random variable x and its probability density function is Px. X for the time being is continuous random variable. Then we define its mean mu x as also expected value, it is an operator. E actually means expectation, it is an operator, it is just a question of notation, expected value of x as okay. Now, you can, how this formula comes, maybe we can give a frequency interpretation. Suppose in the discrete case, suppose x takes some values like x1 or x2 up to say xp. This is n1 times of, if you observe x, maybe on n1 occasion you get x1, on n2 occasion you get x2 dot 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 dot, on np occasion you get xp. So, what is the arithmetic average? Net value is summation ni xi divided by summation ni. This is the total number of trials. Okay. If you can call this as capital N. In that case, what you have is this N1 by, I call off today. Suppose I consider, so this is an exercise. I consider a Poisson random variable, Poisson distributed random variable, where the probability of x taking a value k is given by, let me see, e to the power minus a to the power k divided by factorial k. Okay. A is a parameter. And k can be 0, 1 dot 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 like that. Okay. For this, find out okay. So, that is all for today. Okay. In the next class, we will take it up. Thank you very much.